Good afternoon, everybody. Welcome once again to our seminar on aggregates digitalization. Today, we are going to talk about production control in mineral raw material processing plants. And we have here with us the team from Ma-estro, Andrea Ribezzo, Andrea Bonatti, and Alessandra Tartet. Good afternoon.
Good afternoon.
I think that all of you received an email earlier today informing that we are going to have just one session today. This one in charge of Ma-estro, the one that was going to be led by Arco, it's been cancelled. With that said, dear Ma-estro team, the floor is yours.
Thank you very much, Lorena. So good afternoon, everyone. Thank you very much for your presence. First, we introduce ourselves. So I am Alessandra Tartet, as Lorena said. Take care for the foreign commercial area of Ma-estro. And then at my left, there is Andrea Ribezzo, is our software developer. And then Andrea Bonatti, is our CEO of our company. So I would like to start. We go, okay. By immediately talking about what we do in this project. So our main task is, as I said, to be carriers of data. This data comes from some plants that are involved in this project. We transmit then this data to the large DigiEcoQuarry data collection center that is called Data Lake. So basically, we collect data from 2 pilot sites here in Italy and in France. Thanks, just before, thank you. Thanks various sensors that were already present in the plant and that we installed too. We send this data to the data lake. And another thing that we do with this data is elaborate them and transmit it to our web portal. One of the main tasks in the DigiEcoQuarry project is that the information of the various query can be accessed by smartphone, tablet, or PC through a cloud technology. So as you can see here in the right on the screen, you can see our web portal with the collected data, the elaborated data, accessible by smartphone. You see the machine too. And the various sensors, in this case, this is a volumetric sensors and measure the volume of the material on a conveyor belt. But specifically, who we are. So we were born here in Italy, in a quarry, in northern of Italy, just really near the Dolomites mountain. This is a quarry of our CEO. So he wanted to develop control system in order to optimize this plant first. And when he saw that the system could work very well for other plants, he decided to found our company, Ma-estro, in 2006. What we basically do is first analysis of the plant. So we said every time that it's like to take a photograph of the plant to see clearly all the steps involved in the working process in the plant. And then we decide where or if the sensors are needed. So we install our control system. And thanks to the data that we collected, we digitalize the information in order to optimize and automate the plant. But when we go into the exercise, what we will do is this first step that I previous talk about, so the analysis of the plant. For a matter of time, we will do only the first part of the analysis of this process. And in particular, we would have a look on the working process of a mill and a wheel loader that are working in a crushing plant. We will have few known data. So starting from few known data, we could calculate together how to monitor the working process of a mill. So here near, you can see a video that could show in a clearer way what I'm talking about. Could it be reproduces? No.
Cliccare sotto Ale, su source.
No.
Tasto destro.
Our software developer will solve our problem.
Larghezza penna. Perché questo qui ci con PowerPoint, lo facciamo tasto destro, larghezza penna. La possiamo cercare su YouTube, che dici?
Sì, you can search with the search on YouTube.
Ok, clean.
If you want. Just a second. The video is very important in order to understand what I mean with working process of crushing plant and the various machine involved, like a wheel loader.
Crushing.
Non puoi fare copia e incolla, meglio?
Sì, peccato che non me lo faccia copiare, mi sa crushing. Mi sa che mi è uscito prima crushing.
No.
Production, vediamo.
It's okay. Okay, it's okay. So sadly, it could be not reproduced. Okay. So just to show you.
Ma se vuoi continuo a cercare.
It's not important.
Okay.
So just to show you, all these little mountains are the amount of the crushed material in a crushing plant. So in the background, you can see the excavator or wheel loader has a bucket. The bucket has a capacity. In our case, the bucket will have a capacity of 6 tons. This bucket collects the material that needs to be crushed, and it goes into like this one, the mouth of the machine. So in our case, this is a mill. It's like a crushing machine. So the material to be crushed goes here, and then it will be crushed and transported on all this conveyor belt, and it will be simply all these mountains. All these mountains are divided by the granulometry of the material. This is very important in order to understand what is a crushing plant. Okay, so the exercise. Could you go in the presentation mode? Okay, thank you. So, for example, few known data. If we start from few known data, like the absorption of the machinery, in this case, this is a mill involved in the crushing process. We could know for example, the energy consumption, the cost of the other machinery involved, like the wheel loader here, the produced tons, for example, the CO2 emission in the atmosphere, and the costs that are divided by the various steps of the working process. This is our dashboard. It's our new portal. So we show all this data in this way. In our case, for a matter of time, we will work in a very simplified and as linear context as possible. So as said before, the mill has a mouth. So in this case, the mouth will be have a constant opening, and we assume that the absorption of the machine could be in 3 points. So, for example, in 75 ampere, in 120 ampere, and 200 ampere. Depends on this various ampere. We know that machine could produce at 200 ampere 80 tons per hour of material crushed. In 120 ampere 50 ton per hour, and in 75 ampere the machine simply doesn't work, so 0 ton per hour. You will see a Cartesian graph that will have a linear increasing and a constant trend. So in the real context, in the field context, the line is not so linear, but for simplified exercise, we'll consider the linear line. So you just need to prepare a paper, pen, calculator, and brain, and I give the floor to Andrea for the exercise.
Let's give to the guys some second to prepare these subjects.
Okay. So take your time to take calculator, paper, and other stuff.
Tu sei facciamo le freccette, giusto? Ok, quindi
So.
Perfetto. Ok. Everything is okay?
Loro non ci fanno.
Ah, quindi non ci senti? Okay, perfect. So let's get into the exercise. So as Alessandra already said, we can start from new known data, and then we will calculate together in a way to monitor the working process of a mill. So what we have, the mill's absorption. So as Alessandra already said, with an absorption of 200 amperes, the mill crusher produces 8 tons per hour. Then with an absorption of 120 ampere, it produces 50 tons per hour. And the final point of the known data is the absorption at the 75 amperes, it produces 0 tons per hour. And this is our idle threshold. So what are the main other points of our exercise? The main data are the energy cost, so 0.525 euros per kilowatt hours. The average working time, that is 8 hours at 150 amperes. The idle time, 1 hour and 30 minutes. The cost fee, 0.8, the voltage, 400 volts. The bucket capacity is 6 tons, and the loading cycles is last 3 minutes. Okay, let's jump more deeply into the exercise. So the first question is, how many cycles did the bucket miss? So we can plot on the Cartesian plane the points that we already said. We can imagine this line consistently linear and increasing. Okay, and then we can calculate a constant that is the ratio between the production and the consumption. So we can simply calculate the angular coefficient that is given by the delta y divided by the delta x. So just to substituting into the formula, and then we have the angular coefficient that is 0.376. Okay. Now with a simple substitution, now we can calculate the hourly production of the mill crusher. So the formula is the multiplication between the angular coefficient and the delta x, and we have 28.125 tons per hour. Now let's just multiply this value with the 80 working hours, and then we have the average production that is 225 tons. Okay, let's go through. So now that we have the average production, the number of loading cycles performed by the bucket is the average production divided by the bucket capacity. So the wheel loader on the condition of average production does 38 cycles produced. Okay, we know that each cycle lasts 3 minutes, so we can calculate also what is the time for each cycle. So let's just multiply these values for 3 minutes, and we have approximately 2 hours under load. So finally, we can calculate the cycles missed by the bucket. Okay, with the hourly production available, we estimate the missed production based on the idle hours. So just multiply the average production by the idle hours, and then we have 42.80 tons with the formula that we used already previously. We have the bucket missed 7 cycles. So this is the response of the first questions. The second question that we could let you know is what was the energy cost? We could use the three-phase current power formula that is given by the power factor of the mill, the cost fee, the voltage, the average lead absorption, and we can calculate the energy consumption both at idle and under load using the three-phase current power formula. So P is the power in kilowatt, V stands for voltage, E stands for current intensity in amperes, cos phi is the power factor. We have all this data. The power factor is the shift, the phase shift between the voltage and the current in a circuit. So let's just substitute into the formula, and then we have the idle energy consumption, that is the multiplication between all these terms, and then just multiply for the idle hours, and then we have 62.35 kilowatt hours for result. The final result, the final cost, is given by the multiplication between the cost per kilowatt hour multiplied by this value we just find. This is the idle energy consumption with its relative cost. Now we can see also the load energy consumption under load, the same as before, but this time we have a cost of 166 euros. So this is the final calculation of this formula. Thank you all, and now I can give you, Alessandra, the floor.
Thank you. Okay, so concluding, as you saw with a few data points, a lot of data could be calculated. Now we calculated the productivity of the bucket of the wheel loader. We calculate the missed loading cycles and the energy cost of the mills. All these points are very important in order to knowing the real cost of the crushing plant, for example. And it's important to know in an accurate way the process for optimize it. Now we are in this project. Indeed, why optimize now a plant involved in crushing or recycling processes means reducing carbon footprint. So this is really important. Another fact that I would highlight is the data collection. So the data collection is very, very important in the case, for example, of sensor failure. So the majority of this calculation could be done thanks to the average of the previous values that we recorded from a machine, from sensors, and could be used in order to temporarily overcome. So this is very, very important in order to don't miss a lot of money and a lot of time and optimize the process as well. So thank you very much.